In this lecture, we're going to learn about friend functions. Friend functions are a facility we have in C++ to let external functions have access to private member variables of our own class. Suppose we have a class called dog, and it has a few private member variables. As you see here, we have the dog name, which is an std string, and we have an int, which is our dog age here. And suppose we have a few functions which use our dog objects in different ways. We have the first function here, which is called debugInfo. It's going to not return anything. Its return type is void, and it is taking a dog object by const reference. But if you look inside, we want to print information about our dog object. And we use the dot operator directly to try and access something that is private to the dog class. If we try to do this by default, we're going to get a compiler error because you can't access private members of our dog class from the outside. And we are just using this function here from the outside. This is not going to work. If we go down here, we have another function which is not going to take any parameter, but inside the body, we are creating a local dog object and trying to access its member variable. So this is not going to work also. But sometimes you want this to work. Suppose you don't want to go back in your class and set up member variables or whatever. So for whatever reason, you want the external function to have access to our private member variables in our class, which is dog here. So how do we do this? We can use friend functions. And the way we do this, we declare these functions as our friends in our class. And we put declarations like this. You say friend, you say the friend keyword, and then you say the prototype for the function you want to access any member in this class, including private member variables. The moment you do this, the C++ compiler is going to let this function access anything from our dog class here. So if we put this declaration in our dog class and we try to use these functions like this, they are going to work now because now they are friends to our dog class. Okay, so before we head over to Visual Studio Code and really play with us, here are a few things you need to know about friend functions. The friend function is first declared and alive somewhere. So you can't declare a friend function that doesn't exist somewhere. If you do that, you're going to get a compiler error. The implementation for your friend function can really live anywhere. You just have to make sure that the linker is going to find it when it starts linking your application. But the declaration for the friend function has to show up before you use the function. And we already know this, but I just want to repeat that here to be super clear. The class is going to determine who is its friend. For example, we had to set up the friend declaration from the dog class. It is impossible to set up friendship from the outside. The class that has the members that you want to access has to do the declaration because they are the owner of the data that you are potentially trying to access. The friend declaration can appear anywhere in the class. It can be in a public section. It can be in a private section. So this is really not going to matter. We can have multiple friend functions, and we just saw that we set up two friend functions. And friend function can also be overloaded. And if you need this, you can use function overloading in your friend functions. We have to use the object name member variable syntax here to access stuff from our friend function. We can't access them directly because the function is really not a member. So we have to go through an object and have access to any member from the class. So another thing you should know is that friend functions are really not members of the class. Even if the declaration shows up inside the class, they are not member functions. They don't have direct access to our member functions. That's why they have to go through the syntax we just described here. And because they are not member functions, they don't have access to the this pointer. So keep these things in mind and you're going to be fine using friend functions. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is friend functions. We're going to grab our template files pretty quick and we're going to put them in place. And we are going to open this in Visual Studio Code by dragging and dropping here. This is going to open our project. We're going to clean up the main CPP file. Let's do that. And we're going to close the left pane here because we don't need it. We're going to set up a simple class, which is going to be person. Let's say dog, because that's what we used in the slides a little bit in a little while. So we're going to set up a private section, and inside we're going to have std string, which is going to be the name for the dog, and we're going to have an int, which is going to be the age. After this, we're going to set up the constructor, which is going to live in a public section for this class. Let's align these things a little bit properly, and we're going to set up a constructor. The constructor is going to take two parameters. We're going to say dog here, and we're going to say const std string reference name. That's going to be the name for the dog, and we're going to take an age parameter for the age, and we're going to use an initializer list to put these things in our member variables. So mName is going to be initialized with name, and mAge is going to be initialized with the age parameter, and we're going to put an empty body because the initialization job was already done by our initializer list here. This is our class. And suppose we have another function which is going to take a dog object by reference. Let's go down here and save this. We're going to say void debug dog info. Suppose we have a function like this which is going to take a dog object by reference, and we're going to take const dog reference, and let's call this d. And suppose we want to print information about this dog here. So we're going to say std cout, and we're going to say dog, and we're going to say the information. Name is going to be dname. We want direct access to the member variables. That's what we want to do here. And we're going to say dmName, and we're going to say age is dmAge. Okay, we can save that here. And then we're going to close our output with a square bracket. We're going to put a new line character, and you see that we have squiggly lines here. And the problem is we can't really access the private member variables of the dog class here from the outside. This function debuginfo is an outsider to our class, so it has no business accessing private stuff from our class here. And if we ignore what Visual Studio Code is saying here, let's bring up a terminal and actually see this before we use the compiler. We're going to see mName is inaccessible, mAge is inaccessible from this place here because these are member variables of the class and we can't really access them from the outside. So what do we do? But before I show you the solution to this, let's try to pass this through the compiler and see what is going to happen. We are saying mName is private from this context here, and mAge is private from this context here. We can't really access private stuff from the outside here. So if we want this setup to work, for example, we don't want to go in and set up getters, and we don't really want to mark our member variables as public, let's see that if you mark them public, this is going to solve the problem. Okay, so because now they are public, we can access them here from the outside, and if we build, the squiggly lines are going to go away. So let's see that. You see that now the build is good. But we don't want to make our member variables public because this is going to expose our implementation details to the outside. Other people will be able to come in and, for example, change our member variables, really do all kinds of crazy things. This is bad design. We don't want this. So we're going to make them private, and we want this syntax here to work. Well, we can get out of this problem by marking this function as a friend function to the dog class. And the syntax to do that is really easy. You just grab the prototype for the function. We're going to copy this, and then we're going to go somewhere in the dog class. It doesn't really matter where. You can put this in a public section. You can put this in a private section. It doesn't matter. In this case, we're going to put this first thing in the dog class, and it's going to be in a private section because that's going to be the default access specifier for this class here. So we're going to say friend, and we're going to say the prototype for the function, and then we're going to put a semicolon here. The moment we do that, the squiggly line is going to go away, and if we build, we're going to see that the build is going to be good. Okay, so let's build, and you see build is good, but we are able to access private stuff from the dog class because now this function is a friend of the dog class. Notice that the friendship was set up from the class that owns the data. You can't really set up the friendship relationship from the outside. You can't come in the function here and say, I want the dog class to be my friend. This has to be done from the class that owns the data you want to access. And the dog class owns the member variables that we really want to access. Now that friendship has been set up, we can come in main and really use our function. For example, let's set up a dog object and say dog1. We're going to give it a name, let's say Fluffy, and we're going to give it an age of 4, why not? And then we're going to go down and say debug dog info, and then we're going to pass our dog object, which happens to be dog1 here. If we build and run, we're going to see the information printed out on our terminal. Let's see if the build is good. The build is good. We can bring up a terminal and a clear and run Rooster. Now we see the information about our dog. If we set up another function which creates a local dog object, this is just going to be a way to play with us. So let's go down and do that. We're going to say void printable. We can call this however we want. And inside we're going to create a dog object. And then we're going to print information about this dog directly from this function here. This is another setup you might want to do. So let's do that. And we're going to change D to dog1 here because that's the object we want to print data for. So we're going to say dog1. And we're going to have the same problems. This is an outside function. It can't really access the member variables for our class here. And just to show you that we can use overloads, we're going to name this function debug dog info. I think this is going to work because the parameters are different, but we still have the same problem. Dog1 is a dog object, and we are trying to access private members of our class here. And for this to work, we should also mark this function as a friend to our class. So let's grab the prototype. We're going to go inside the class and we're going to say friend, and we're going to put in our prototype and put a semicolon here. And the moment we do this, we can go in our class and say debug dog info, and then we're not going to pass anything in. Let's comment out the printing line we had before, and we're going to see that we are going to see the information here. Let's change the name to Milou inside here and change the age to 3, why not? And then we're going to build. Okay, the build is good. We can clear and run Rooster. This is going to print our information, and this is working because our functions now are friends to the class, so they really have access to private members of this class. They could even modify information about our class objects. So for example, we can go in our class here and change the name for the dog. We can come in here and say dog1 mname and change this, and we're going to change that back to Fluffy. And you're going to see that this is going to work because this guy is a friend to our class, so they have access to our member variables. They can read or modify our member variables. Now if we print, we're going to see Fluffy even if the dog we declared had a name of Milou. So let's see that. We're going to build with GCC. The build should be good. We're going to clear and run Rooster. We're going to see now the name is Fluffy, and we have successfully changed this from a friend function which has all access to our member variables. So hopefully you can see that friend functions can really be dangerous because they allow people to do crazy stuff with your objects from the outside. So as the saying goes, choose your friends carefully because they can do crazy things to your private member variables. So this is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how we can set up friend classes and give them access to our private member variables. Go ahead and finish up here and meet me there.